Testing, microphone testing, testing. This is Stephen Smith. The date is 9/19/2018. This is the regularly scheduled class of ITSC 2347, live and direct from beautiful downtown San Francisco, Frisco, Texas, the most desirable place in the United States to live, or so I understand. Okay, I'm getting a start about 2 minutes early, so maybe we'll finish up 2 minutes early. What do you think? Tonight, we're going to talk about something different. We started off and we started talking about SQL programming, TSQL. I could have chosen any language and they'd all been about the same. They all do if then else. They all do while loops. They all have procedures. The procedures work about the same way in all of them. There isn't much difference. If you know how to write a function in one language, you know about how to write it in any other language. If I can drive one car, I can probably drive all of them. I might have to stop and figure out where the windshield wipers are if it starts raining. But in general, most of the things are about the same. I know there's some wipers up there someplace. When I was a young person, I had to, the dimmer switch to turn the lights high and low was on my left foot. I had to push a button with my left foot up under the parking brake. But that was, I also had to walk to school 2 miles through the snow. Each way, all that jazz. As we go through this, though, we find places where the languages start to differ fairly radically. Tonight, I'm going to give you something that is in every language, but it will be something that is quite a bit different from one to the other. So Oracle will treat it differently. And this is the idea of triggers. Now, procedure is a procedure. Function's a function, about the same in all languages, but a trigger is essentially a program, a computer program that executes in response to a change or something that might change data. So it executes in response to an insert, an update, or a delete statement. Select statements don't fire triggers, but the ones that change data can fire triggers if you've written a trigger for it. Let's take a look at an example up here. Make sure I'm still recording. Am I recording? And checking. I am recording. Okay. Using my Scratch database. Notice that I have 3 drop statements up here, fairly simple ones. Look, I have 2 views and a table. I typically drop my views before the tables, but I don't believe in TSQL that you have to. I think you should drop a table because the table depends on the view. Excuse me, other way around. The view should be dropped first because it depends on the table. Okay, I tried it the other way just to see if it would work, and it worked okay, but I think we should drop the views first. The table is just pretty plain vanilla. Tables should go in their own Go block. I have a table. I have a name, somebody's name, client name. It's a primary key. I'm doing it the fast and dirty way. C active is essentially a Boolean. A tiny int, remember, is a 1 byte integer. It can hold values from 0 to 255. That's just about as small of a memory piece as I can efficiently access. Once upon a time, they tried to put 8 Boolean values into 1 byte, and it was a dismal failure. So they scrapped that in about 2007 or so. So it's been a while. He defaults to 1. And this is how you do a not null constraint if you are just playing it quick and dirty. Two fields. Okay. Here's the view. create a view, active clients as, select name from clients where active is not 0. 0 is false. Anything else is true. So you're an active client if that C active field is not 0. Anything else? If it's 0, you're inactive. If it's not, it defaults to 1. So when I put you into the table, you're active. And when I take you out, okay. Now, basically, create view must be in its own Go block, must be bracketed by goes. It won't work if you don't. As, and then any select statement you want to put. And now I have here this last one, with check option. Okay, if you use that option, with check option, what that means is that I cannot modify that view using the view. I cannot update. Now, I can update a view, and I will update the table underneath it, as long as that view is not too wild. Obviously, if you have tables joined, which field are you talking about updating? It might not be able to. Obviously, if a view has a one of the cumulative functions, an aggregate function is what I'm trying to say, like average, I can't update the average. It's based on the average of a bunch of things. So you can't update all views, but most views you can. This view, I could update the C name just fine. If I put the with check option, I am restricted from updating that view in such a way that the record no longer appears in the view. So it drops out of the view. Okay, it's a security feature. And when you're using it for security, that's what you want. Now, I cannot update, since C active has to not be 0, I don't have C active in the view. So there's no way I can do it, so that with check option does nothing for me here. I just thought I'd mention it. If you put with check option, that would stop you from setting C active to 0 if I had C active in the view, because that would cause it not to be in the view anymore. The reason for this is many times views are used to implement security. The human resources people can see all other records except human resources. That's probably a view. And then payroll probably handles human resources records. And we don't want somebody to be able to change a field and send the record into the other view. It would. You cannot. Updating the clients table. No, it's not. It's not on the clients table. It only affects the view. So typically, what I'm going to do is give my people, my users, access to the view, but not to the underlying table. They can see all the records. They have a view that says active clients. They have a view that says inactive clients. They can see everybody. They just have to look at it through two different views. The clients table contains everybody. But the users cannot move people from one to the other, and if they can't get to the clients table. And I can stop them from that. We're going to talk about that. And I bet you've probably guessed that inactive clients, where the view is 0, it's everybody else. So this one where it's not equal to 0, and this one's where it is equal to 0. So together they give me the whole table. I have to worry about that being null, but it's constrained against null. Okay. Questions on my initial setup? Pretty straightforward. All right, trigger. A trigger executes in, trigger must be in its own Go block, creating a trigger. A trigger executes in response to an insert, delete, or update. It has two ways that it can execute. It can execute before the SQL statement executes, or it can execute after it and check it. Okay, two ways. It's called its coupling mode. It's when it can happen before. Now, the words that we use for that are when it happens before, we say that's an instead of trigger. When it happens after it, we say it's either an after. You can use the word after or the word for. Either one, they're pretty much interchangeable. Personally, I like after better, but I think it has been superseded by for. Questions? So a trigger is code that executes on an insert or an update or a delete statement. One block of code has to be triggered to each one. Okay, I'm going to come back to this a second. Let me show you this one. This is a create or alter trigger. This is a trigger called delete client on clients instead of, in other words, before delete, do this instead. Don't delete, do this instead. What do you think I'm going to do? I'm going to update that field to 0. Instead of deleting it, I'm just going to set that field to 0. Okay. Now notice that I am updating the trigger is on clients. So I write through the active clients, I delete from the active clients. I write through the active clients. I hit the underlying table. The trigger is there. That's typically the way they do when you're on a view. You can trigger a view, but most of the time you trigger the underlying table. Okay. Now for the fun part. A trigger receives up to 2 tables from the system. So when it executes, it receives up to 2 tables. I didn't say 2, I said it could receive 2. Depends on what kind of a trigger it is. A delete and an update both receive a table named deleted. They have access to it in the body of the trigger. And we'll see it happen here in a minute. It contains the rows that are to be changed in the future. So if I'm going to delete, I have a table that says, what rows will I delete? If it's an update, what rows will I update? On Oracle, this is called new, the new stuff. Right, the stuff that's coming in. Okay. Insert and update both receive, excuse me. Okay, deleted, which contains the rows to be changed in their original state. Insert and update both receive a table named inserted, which contains the rows in their changed state, but the table hasn't been changed yet when they get that. So it says, okay, this is what I'm going to change, this is what I'm going to change it to, and the table has not been changed yet. Deleted and inserted? No, it's a temporary table that exists only just for a brief split second in as the trigger executes. It doesn't stay there. A lot of stuff out there on it in Google because this is a real complicated idea. Let's look at a trigger. Maybe that'll help. Okay. Create or alter trigger. In Oracle, you would write create or replace, but that's not much difference there. It has a name. It is on an object. For example, usually it is a table. It can be on a view. Most of the time it is on the underlying table. Because if you have only certain rights on the table, it doesn't matter what rights I give you on the view. Instead of delete. In other words, before you delete, do this instead. In a view, begin and end are optional because it has to be in its own block. Therefore, the go has to end it. So I personally like using begin and end. So I will. But if I took them off, it would be the same. I print a trace. Triggers typically do not talk. I put that note there. Triggers do not usually print, but they can. They can do anything. A trigger can do anything. A trigger may be written, a trigger does not have to be written by the database owner. A trigger can be written by the system administrator. Therefore, a trigger can delete the whole database if it's written by somebody who can do that. So a trigger, there's no limit to the power of a trigger. It can do anything. I'm the owner of the database. It can do anything the owner of the database can do, which is much with that database. What does it do? Instead of delete, updates clients, set, CActive, it's 0, where CNAME is in, little sub-select here, very straightforward one, select CNAME from deleted. Go through the table, everything that's in that deleted table, don't delete them, just set the CActive field to 0. If it's 1 or 20, I can say delete the whole thing, that'll work. I really like it when a trigger is a nice, simple SQL statement. I don't like complicated triggers. Okay, I don't like complicated triggers if I'm going to be doing a batch of inserts, if I'm going to be saying delete everything or insert multiple rows, batch rows in one statement. I like those. That's a fairly simple trigger. Let you pause a minute. Go ahead, please. What's that? It is a table. It is a system table. It is passed, think of it as a parameter to the trigger, but it's not really a parameter. It is a temporary table that the trigger has access to. It is a list of all the rows that will be changed. I can take a count of them and see how many I'm going to change in there. I could count it. I could say select count, splat from deleted. That would tell me how many rows I was going to change. I can join deleted with another table. Inner join, outer join. This one is a sub-select. I could have used a join here. So I just say delete client, update clients, set it to 0 where the CNAME is in that table, the deleted table. That's the simplest way I can think of. You could probably think of a more complicated way, but that's a simple way I like. Questions, observations? Your first trigger. By the way, this is the classic example. You do this a lot. If you work in a doctor's office, you do not delete records. They just get a field set to 0 or 1, and when it's set to 0, they just become inactive records. They don't even move. That record didn't move. It just got set to 0, and it moved from one view to the other, logically. We'll see that happen in a minute. Insert on clients instead of insert. Insert is going to get a little trickier. There's 3 things that could happen with insert. One of the things we try to do with triggers, we try to keep us from ever hitting the table constraints. I never want to hit a table constraint. I want my triggers to stop me from hitting that. Table constraints are my last line of defense. The triggers are my next to the last line of defense. So the triggers are supposed to catch it before it gets to the table. So I should not ever get into a table and violate a primary key. The trigger should stop me from violating the primary key. Don't try it, just stop. Now, if the trigger throws an error, that's fine, but the trigger catches it, then I caught it before it got to the table constraint. Before you got actually into the table, you got stopped, okay? So I'm gonna insert something into active clients, okay? Actually, this is insert client. This is inserting an active client. I should have called it. But this trigger is going to insert an active client. So it's when you go insert into active clients, it's going to reach through and it's going to hit this trigger in the clients table when you're doing an insert. There's three possibilities. What are these three possibilities? One, never saw that record before. It's a brand new record. It's not in my clients table. It's inserted, no problem. Option two. Wrong data type isn't going to compile. I've already got that record. It's already in the active table. If I try to insert it again, I'm going to hit the table constraint, and I don't want to do that. I want to catch it here. So one, it might not be there. Number two, I already have that record as an active record. I am not going to call it an error to insert a record that's already there. Okay, I don't, typically speaking, I say it's not an error. By the way, if you go up and look at the delete, it's not an error if you delete a record that isn't there. It's just, before you started that, I don't know. After that's finished, the record is not there any longer. Okay, when you insert, before you start, I don't know what the state is. After you finish, the record is there if it was a valid record. Okay, so one, don't have the record, insert. Two, record exists, it's an active record, don't have to do anything. Or three, the record exists and it's an inactive record. In that case, make it a 1. Set the active field to 1. Now he comes out of the inactive and goes to the active. I didn't really insert him. I just changed the field. So there's 3 cases. 1, I actually do the insert. 2, I just change the field to move him from the inactive to active. And then the third one is he's already in the active table, do nothing. Okay. Let's see what happens. Begin. Okay, first one, I'm going to insert. Do you remember these set operations? Chapter 6, I believe. Except is essentially set difference. So insert into clients. We didn't do a whole lot of this, but insert into the clients. Select the name from inserted. So insert all the names except those that are already there. Inserted is that temporary table that is passed to an insert or an update statement. Deleted is passed to a delete or an update statement. So inserted has the rows that are coming in. It can get a little more complicated if you have a lot more rows than that to insert. But this is the simplest case. The logic doesn't get much more complicated, but the syntax can. So I'm just doing one field. Makes it easy. So insert into clients, the CNAME. Everything that is in the inserted table minus everything that's already there. So I won't have any duplicate primary keys. Insert everybody. After I have finished inserting everybody that I don't have, I'm going to run one more SQL statement. Update clients, set active gets 1, where CNAME is in. Select CNAME from inserted, just like the other one. Now, you might say, well, I call that kissing a toad. There might be one in there that's already a 1. In fact, there probably is. There might be a C active in the clients table. It's already 1, and I'm saying select CNAME from inserted. Okay, so what? But if there are any zeros, they get changed. You could do a table join here, and instead of just over here in the sub-select could be a table join. So you could join the inserted and the clients, but I'd be spending as much time doing the join as I would be just to go ahead and change them all. Set everything to 1. The ones that are already 1 are just still 1. The ones that were 0 changed. Here we have some insertions, insert Tom, Bob, and Jim, and then I do another insert Jane, June, and Sally. I ought to end up with 6, and then I have some test routines. I'm going to go ahead and execute everything. By the way, I get some output from it. Insert trigger fires here. Here's the two SQL statements fired. You can turn off that. You can turn off that trace. That's called the trace. If you execute the command set no trace on, and most people do that. Set. Okay.
Is it possibly no count?
No count?
No, without the others.
Well, that one's turning. Okay. I guess it's no count. Yeah. No, it's the count of rows that it's changing. I don't usually pay a lot of attention to it because I typically don't run a whole lot in this area. I don't do a whole lot of printing to the screen, but I just put those. Those are called tracers. Show when the insert trigger fires. It fired 4 times. It fired once each for the 3 individual inserts, and then one more time when I did the bulk 3 value insert. So there's 4 executes. I'm not sure. Yeah, you got to set it to off. Once you set it on, it stays on. Okay, so let's run some test routines and see what happens here. So I've got I have 6 records in there. If I select everything from active clients, I see my 6 records: Bob, Jane, Jim, June, Sally, Tom, 6 records. If I select everything from inactive clients, what do you expect me to see? Nothing. Okay. If I take a look at everything from clients, because I can, if I were a public user, I wouldn't. I see everything and the see active. Now let's delete from active clients. By the way, this is going to delete all of them. Whammo. If I execute this, there went the delete trigger fired. And so what happens is I'll just look at clients, I see my clients, but they're all 0. That means they're all going to appear in the inactive view. So if I select from inactive clients, I'm going to see them all. If I select from active clients, I'm not going to see anybody. Oops, I made a big mistake. I just deleted everything. I can insert into active clients from select. I can get them back, execute, and now they're all back into active clients. I don't have to delete them all. I can just delete Bob. Goodbye, Bob. Nice knowing you. Bob is still in my table. All of Bob's records are still there. All of the doctor's notes and prescriptions and everything are still there. The only thing that happened was one little field changed from a 1 to a 0. So if I go up here and if I look at active clients, I see everybody but Bob. I see Jane, Jim, June, Sally, Tom, and I find Bob over here in the inactive clients, and there is Bob. Insert into active clients. Let's see how this works. What am I inserting? I am inserting Bob. Well, Bob is an inactive client. He's getting inserted, so he's going to go from inactive back to active. I'm going to insert Sam. Sam is a client I've never seen before. He's new. So Sam's going to come up in there. Now I'm going to have 7 clients. Jim is already in the active clients. I expect him to stay there. So when I execute this, in active clients, I'm expecting to see 7. I see 7. I see Bob has come back. I see Jim is still there. And I see Sam has been added. What else do I have? This one bombs out. Delete from active clients where C active is equal to 1. Why will this one not work? It's nothing to do with the check. Say again? No, it doesn't. It isn't the constraint. What? Invalid column. Why? It's not in the view. Now, if I said from clients, it would work. It would delete them from clients. Well, no, it wouldn't. It would just set them all to 0 because it hit the trigger. You cannot delete a record from clients unless you go get around that trigger. You can't get around that trigger if you don't own that table. So what I'm going to do is I'm going to give you the privilege is here. So I give you privilege to insert into active clients and inactive clients. You insert into active clients. You don't need to insert into inactive clients. If you insert them, they come in as active, and then you can delete them. So you get to insert, select, delete from active clients, and you get to select from inactive clients. And that's all you get to do. You don't get to see clients. You don't know how it's happening. You don't know what's going on under the table. There's no way you can get around it. Questions? This is a very common example. It's probably this one I usually start with when I'm discussing triggers. We understand it.
When you update from inactive client to active client, you actually delete one row and add another row.
No, when I delete, or I don't delete anything in any of these triggers. Yeah, there's three of them there. Well, here, Bob, for example, Bob right now, when I did it a minute ago, Bob was in the inactive table. He goes from a 0 to a 1. He goes from a 0 to a 1 right here. He is in inserted. Therefore, set active gets 1. He goes to 1. Because his name is in inserted. Bob is in inserted. So he gets a 1 in his active. Look at the other one. Sam. Sam does not exist. Sam gets inserted into the client's table. He's already in the client's table. Jim. Jim is never, because Jim is not in Jim is already in the client's table. So since he is already in the client's table, he gets filtered out right here, because this is the difference. It says take everybody that's already in the client's table out. So he's not inserted, and he already was a 1. So the next one doesn't change him. He just doesn't change any. So I put all three of those in there to show that they'd all get inserted. And if you insert Jim and Jim's already there, I'm not going to call that an error, because the post condition is that he's there. Well, the post condition is met. People get in big arguments over that. Is it an error for me to remove a right from you that you don't have? I revoke your right to see certain files, file A. So I revoke it. Well, what if you didn't have that permission, that right? Start with, is that an error? What do you think? Yeah. Okay, is it an error to delete something that is not there? It might be, I mean, do what? Oh, I don't want to get into the comparison or what we're doing. Just, is it logically an error if I say delete something that's not there, or if I grant you a right that you already have? Is that an error? No, because after that happens, you have to have the right. The fact that you had it beforehand, I don't think changes anything. Maybe. I'd need a way, then in that case, I'd give you an observer that would tell me what your rights were. If I delete a right that you didn't have, the only thing I really care about when I say I delete your right to fly or whatever, after that happens, you don't have that right now. I don't know what it was before. And that, I can see it different ways. You know, if you say to delete a file and that file doesn't exist, then error level is going to get set. Okay. That's how it works. But I don't see it being an error to insert something that's already there or to delete something that's not there. In my scheme of things. Questions? Okay, I'll let you guys look over this. Save. Where am I saving? Okay. What fun. This is going to be our project. We're going to get intimate with this thing. Actually, this is a very common project. And it's been written about every possible way and every possible language and I see it written in, if you Google rock, paper, scissors code, you'll find it written in Python, you'll find it written in Fortran, and everything in between. We're going to write it in T-SQL. Okay. So rock, paper, scissors. Now, I'm going to give you my vision, but my vision doesn't have to be yours. Although I suggest you pay attention to mine. I've written it a few times. Okay. Now, I see there are four tables, but really 3 of them are our working tables, 3 tables and an error table. So we're going to run a log on this. Anytime there's an error, anytime something slips through, we're going to log it at whatever level we catch it. So sometimes if we catch it at a very high level, I'm not worried about it. It didn't get in at all. If it gets through our first level into our secondary defenses, now we got to worry more about that thing that's slipping through our safety net. We'll talk about that. We're going to have a defense in depth on this thing, just as if we were defending money down there in these tables. We're not going to let people come in and just get their grubby little fingers in our tables. And we're going to create a user that is a public user. This user will have no privilege at all except what we give to public. We're going to be very careful about what we give them. The problem with computer security is not that you can't secure it. You can. There's just so many things you have to remember to secure. And it is so easy to forget one little thing. So easy to forget that one little door that you didn't lock. We have a competition that we do. We call it the Collegiate Cyber Defense Competition. And we give students computers to secure, and I don't really, then we have a team of people come in and try to hack into them. I don't think that's very good. I think what should happen is that the students should form their own red team out of the students. And instead of being enemy hackers, their job is to help secure that network and find those holes and get them closed. And so the competition should be who can get them all closed the fastest. But the common thing to do is the database is owned by a user. The user that you used, the Windows user that you set up the database with, that user has a password. If that password is vulnerable, your whole database is vulnerable at a very low level. If I can crack your user's password, if your user's password is X, I've got that in a rainbow table easily. It'll take me about 10 seconds to log in as the user. Now I can connect as the Windows administrator. I'm in. So everything that you got to secure. We're going to talk about that. Okay, let's back up and take it one at a time here. It's going to be a major programming project where we will develop a complete application, and we're going to span the semester with this. We're going to go from here, and we're going to span into the second half where we're going to go, I think, if I dare, go into Access Forms and link Access Forms to SQL Server. Access Forms are great. Microsoft Access, you're right. This class isn't about Microsoft Access, but we can definitely use Microsoft Access Forms to link our SQL Server forms into it, and Access Forms and our tables into Access Forms. They'll run just fine. Access is like, or SQL Server is Access's big brother. They're very compatible. And many, many times you will find Access Forms running on top of SQL Server. That's a great interface. SQL Server doesn't have as good of one as Access does, and reports. So you can build all that stuff. Okay. Let's see how far we can get with this. I think I'm going to use this instead of a test. I see the project has 4 tables. The first table, the highest level table, is the RPS players, or maybe you just want to call it players. I don't know. I call it whatever. So a player has a unique identifier, and I say you need to think about how you're going to do it. Are you going to assign that unique identifier from a sequence, or are you going to have the user choose his or her username? And it just has to be unique. You can use a sequence, give 1, 2, 3. I don't want you to use identity. If you're going to assign them values from a sequence. Remember we talked about creating a sequence? Create sequence and then sequence next value from that sequence. It's like take a number and you always get a unique number. You can start, for example, you could start with your players, start with 1 increment by 2, so you go 1, 3, 5, 7, 9, and then if you wanted to insert and you inserted an even number, you'd know it would work. So you're leaving yourself some space. Go ahead.
So in this case, the table player,
no, it's not going to be optional. The players, let's talk about just the players. A player has a player name or a player ID. Now, I think my choice, the way I'm starting off the example, was I just made it up. What's your nom de game? Well, my name in the game is Stephen. It can't be. And then I also have a real name. Okay. A player has a date of creation. Those are the required fields. There may be other fields. Maybe you want to put a password in there. Maybe you think leaving room for a password would be a good idea. We're not going to use it right away, but you might use it later. Yes. Mm-hmm. Sure. Right. Mm-hmm. Sure. That would be valid. You can have other fields. There's some of them are good, some of them aren't. Active, inactive, yeah. Right. Yes, we're going to have as many players as we want. Once you go into the table, you're in the table forever. We're not going to delete you. Only 2. A game has 2. Well, I haven't gotten to the game yet. We're going to get to the game next. Players, big table full of people who have signed up to pay me money to play my game. Right? We're pretending they're paying money for it. So we have, okay. Games. I have written this with RSA encryption on it. RPS server and TCP/IP programming in C++, in C and Java, and Visual Basic for the interface. A game has a unique identifier assigned by a sequence. So that one's just 1, 2, 3, 4. A game has a date of creation. Here's the important piece. A game has 2 unique foreign keys referencing the player's table. What's your problem here? The names can't match, can they? We've got 2 of them. Well, you'll have to think of something. I said that you should make your foreign key match the primary key in the reference table. But you can't do that here. That's okay, you don't have to. They can have different names. Okay, this next one is do not allow. Well, you'll have a player 1 and a player 2, and they'll reference player ID from the player table. They both, two different players, both referencing the same table. Yeah, you'll be referencing, so player ID for player 1 will be King Kong, player ID for player 2 will be Trashman, and that's not a problem. When you name those 2 foreign keys, we like it when the name of the foreign key matches the name in the parent table. But I'm going to have to append a 1 and a 2 to it. But that's nothing. Next one's a little trickier. Might want to think how you're doing this. Do not allow any 2 specific players to be involved in more than 1 game together as a pair. Even to order. So I'm saying here, if Bob and Jim, assume they're primary keys, have a game established, then that must be the only game the pair has. If Bob is player 1 and Jim is P2, I'm calling them, and I don't care if you call them that or not, we won't allow a game where Bob is P2 and Jim is P1. So we won't let them be switched. Bob and Joe, Jim and Tom, Tom and Bob. Yeah. You just, Jim and Bob cannot appear as the 2 players of any other game. That will confuse us greatly because the question then, if I put in Jim, I need to ask, well, what games is Jim in? So I can pick one of those to play the game. So, right. Now you can sort them. So if Bob is greater than Jim, Bob gets player 1, else Jim gets player 1. You could do it like that. That'd work. And then just check them for uniqueness. Lots of ways to do it.
I'm not sure about understand the last sentence. Bob is a P1, Jim is P2. Even though they switch, they are in the same game, right?
Right. If Bob is player 1 and Jim is player 2, then they cannot have a game where Bob is player 2 and Jim is player 1. Well, it would be the same game, yes. They can't have a second game. Bob and Jim can only be in 1 game together. Okay.
They meet one time and then later on they could meet again, as long as they are not in each other.
Well, the game that they are in will persist forever. So Bob and Jim decide to play a game. They're married from now on. Well, can they get out of the game? I suppose there's some way. We just haven't written that yet. You a certain number of plays, and you could do that. Right now, I think it would be best just have forever games, right? When Stephen and Mary are in a game, no game can exist with Mary and Stephen, and it is in reversed. The game goes on forever, and I mean, do you ever win World of Warcraft? I don't mean either, but I mean, does anybody ever like win? Okay, you're the winner. Yeah. I mean, it doesn't happen. You never lose either. Okay, you lost, you're dead. You can't play anymore. Right. Okay, games. So a game has a unique identifier, a date, and 2 players are the minimum set on there. Now, notice one thing that's not in the game. A game doesn't have a score tied to it. Game doesn't have a current score. Has to have 2 players. Hmm. I guess you can play rock, paper, scissors, lizard, Spock. The logic is the same, though. And finally, RPS rounds are just rounds. A row in the rounds table represents 1 play by each player. A token, what I'm calling a token is an individual play, R, P, or S. A round has a unique identifier assigned by the sequence. And yes, we will need a different sequence for each table. So we need 1 to take for the rounds table, 1 to take for the games table.
We assume that one table is more than 2 players or just exactly 2 players?
In the players table,
Yeah.
you can have an infinite number of players.
All right, and then I go back to the game table.
Okay. Let's talk about the players table. I can create a player named Al. I can create a player named Bob. I can create a player named Cynthia. I can create a player named Donna. I can create a player named BCD Ed. So there's 5. Now I can have a game between Al and Bob. I can have a game between Bob and Ed. I can have a game between Donna and Cynthia. I can have, how many games can I have there? 5 factorial. I can have 4 times 5 is 20 times 3. I can have 5 factorial games. I believe that's 120.
Because the game is infinity, you're not going to end it. So if
That's not, you're asking how many games we can have. It's 5 choose 2 is what it is. It's not 5 factorial. But as many ways as you can choose 2 unique pairs that are unordered out of a bag of 5. So I have 5 marbles. How many different pairs of 2 marbles can I pull out? I don't worry about number.
No, even an odd number. So because the player needs to be 2 players to work, you're not playing 3 players.
Right, you must have 2 players.
So that would be the even number.
Yes, 2 is an even number. You must have 2. It's more strict than even number. It says you must have 2. A game has exactly 2 players.
Okay, the number of the people should be even number.
The people where? The number of the people shall be even. What people?
The people who, so
The people in the players table. Okay, here.
am I wasted everybody time or I can do
Well,
it?
players,
Everybody
catch.
understand or just me? I don't-
No, I want to hear your question. Because
So the
I think
question,
I understand.
okay, so the question is, so we have a P1, P2, right?
Well, what are those? Are those?
P1, P2 is a different table, right?
Which table is that in? Tell.
So this is the table 1, this is the table 2.
Which one is the players table?
They all play the table.
No,
Player need
actually,
to play in the table, right?
I think your issue is actually we only have one player table.
Yeah,
rather
one
than
big player.
There's one player table.
Okay, so that's a one player table. And how many players is it?
Infinite.
Infinite. Okay, so that's using your example 5, right?
Could be 5.
Could be 5, right?
P3, P4, P5. Okay.
So,
Now erase those two up there.
so the
Now you have a games table.
so the
Those are just players. P1, P2, P3, P4, P5. Now go to the games table. Draw the games table, please. Draw a circle. Make a circle for games. Now, you got game 1, G1. Oh, stop. Stop. Let's just do G1 first. Which 2 players are involved in G1?
that's a P1,
P1, P2. Now you got another game, G2. Which 2 players are that? P3, P4. Got another one, G3. Which 2 players?
So this it will be even number.
No, you can have any P1. You can have P1. Anybody except P2. P1, P5, P1, P3, P1, P4.
In game 3, like a P1, P5. This is the infinity game. P1, P2 never end, right?
True.
So how this P1 come to this game 3? It won't never.
He's in both games. Do not allow any 2 specific players to be involved in more than one game. If you had, okay, G4, put G4 off to the side, G4. Now, this is wrong. P2, P1. That is a violation. That is violation.
Yeah, I know, because those are same people, same game, right?
Yes,
Game 1, game 4 is the same.
yes. So erase game 4. You can't have a game 4 with those 2.
What his question is how is it possible for one player to be involved in more than one game at the same time?
Because you can be.
You can actually imagine that if you are doing an online game, you can open one tab doing one online game and the other tab with the other player to do exactly the same game.
That's exactly what we're simulating.
So
So you.
yeah.
And then the rounds table references the games table. So draw the rounds table. Let's just put 1 in there. So this is rounds. So we might have an R1. And then what is it? And what game is it associated with? G1. And what is player 1's play? R, let's say. So R. Put G1, comma R, comma P. So what does that tell me? That tells me that that round belongs to the game number 1, and that player number 1 chose an R, player number 2 chose a P, and it's time-stamped. Test.
A little-
Right. I mean, there is no such thing as infinity in a computer, but there is no arbitrary limit.
So what is R1 right there?
R1 is round 1. Well, he's got too many values up there. Round 1 would have only 2 values. It would be R and P.
Okay.
And then R2 could also be associated with G1. It could be two different ones, PS or SS. Then you could have R3, so you have round 1, round 2, round 3, all of those associated with G1. That's confusing me.
That's all.
Well,
right?
right. I don't know what you're doing there.
But what is
I'm going to take this microphone off for a minute.
so the first, no, those aren't games, those are rounds, aren't they?
Right. Yeah. The rounds table, it has an ID, okay, and that might be R1, round 1. But just one. What game? All of that one is associated here. R, P, and a timestamp. So who played R? Oh, G1. Who's player 1? P1. Over here I can get P1's name. Real name or username. Then I might have another one. R2. Also with G1. They're busy today. R. R3. Also with G1.
And in that is that fourth column always your first player? Is that always P1? Is that always is that always P1
It would,
play?
the position of it would tell you what player it was.
Okay.
So it has a name, and and if you go in there, that will tell you its name. So whatever the name of this column is.
Okay, but in this case, it's round, it's game 1, and you know that game 1 is P1 and P2, so you know that's P1.
I know game 1.
Because you're looking back there, right there.
I follow it back up
Right,
here.
so you know-
These guys.
So you know
Follow
it's
it from
P1
here
and,
to here. I get his name, date of birth,
okay, but you know it's,
bank account number.
yeah, so you know it's P1 and P2, so you know that P1 played R and P2 played P.
Right.
Okay,
And I can associate them back
yeah,
with these, and I can tell you how many games. So based on this, I can get the winner,
sure.
and then I can come back, follow it back, and I can tell you how many games did P1 win.
Mhm.
I can tell you who won game 1, who is now winning game 1.
So I think before you were calling the rounds plays, weren't you?
Baby.
Okay.
What is this one? This one is G3.
Okay.
Wrong. So this one is associated with game 3. Game 3 has P1 and P5. Follow them back up there. What's his name? What's his date of birth? What's his bank account number? Send P5. That's in the players. Here we got players. Games. Round. All of these guys have been secured. Get secured. It's time for a break.
Yeah, it would be interesting.
Okay.
So thank you for asking that question, because I think it led to more clarity.
I'm sorry I walked away from the microphone there to go up to the I'll have to clarify this. I'm going to write some more in Word because I don't think that it's quite clear what we're doing. It's clear in my mind, but it doesn't appear to be the same in everyone else's, which is quite common, believe me. I'm going to pause the recording now. Okay, we are back from break and moving along. Here's my example. I suggest that you create a database called RPSDB. I'm going to do that. So I'm going to go to the Object Explorer, go to Databases, New Database, RPS. How did I call it up here? RPSDB, okay. RPS_DB. I'm going to make the owner be SW Smith, and all I have to do is say okay. Well, how am I connected here? I'm connected as maybe I just wasn't connected. New database RPS_DB. Oh, okay. I'm going to, in order to create this, I'm going to have to connect as Windows authentication, because to create a database, I have to be, at least for now, I have to be the administrator. So create the database, RPS DB, make the user, make the owner, SW Smith, and that creates it. So I have to log in as with Windows authentication. And now I'm going to go back. SQL Server. Okay, use RPSDB. And I can do that. So I'm going to create the RPS players table, and this is going to show you kind of what we're going to do with this. So I'm now getting ready to create the table. So if object ID RPS players is not null, drop table, I don't have a problem. If you call it players, but be thinking about your naming scheme, because we're going to get an awful lot of names floating around here. As you build anything that's of any complexity, you're going to have lots of names. Okay, here I'm creating the, please? Yes, identifiers. What are you naming your tables? Pay attention to it. I'm naming mine RPS players, RPS games, RPS rounds. A player has a player ID that they choose. I'm going to let them choose it. They have a date, and they have a real name. Their mother chose that. Okay, the constraints. Constraints, I have a primary key. Now remember, I don't ever want anything to get in here and hit these constraints. Players, 0 length. In other words, you cannot put a primary key in there that is the empty string. It has to have at least one character in it. You can get away with that, yes, for one of them. Check that the date is not null. Check that the player's name is not null. I don't have to check that the primary key is not null. Check the player's name not null, and check that the player's name has at least one letter in it. Okay. Constrain everything I can. Player's name does not have to be unique. I can have many players named Joe. The player's ID has to be unique. Okay. You might want to write a function that checks a player's ID, a proposed ID, and says, can I use this? And that kind of says, okay, the player types it in, you go check it and see if it's any good. No, sorry, that's no good. Trigger, okay, so these are the last line of defense. Second line of defense is the triggers. Okay. When you try to insert on RPS players, instead of inserting, I'm going to do this. Begin. I'm going to declare PID, PName, and count. Now, notice that this is a local variable with the @PID. It is the same name as the one in the table. I like that okay. Right? Because of the way that these local variables always have the @ sign. That's one of the things I'm not worried about, the @ sign. I like that okay. So here's an ID and a name and a count, integer count. So I count from inserted. Okay. Something I didn't mention about triggers. It's a trigger. If a trigger is complicated at all, it becomes very, very difficult to allow you to do like a batch delete or a batch insert. So this is going to be a fairly complicated trigger. I don't want you to be able to insert values Joe, Tom, Bob, Bill in a row. You're going to have to do the inserts in each step. You're not going to be able to do the big batch insert. You know what I'm talking about, where you separate them by commas? Insert into players, PName, values, and then you Joe, comma, Tom, comma, Bob, comma, Bill, comma, Jane, comma, Sue. I don't want you to be able to do that. Not that I don't want you to be able to do that, but that's going to make my life real complicated in this trigger. It's a lot easier if I could do it just one at a time. So what I'm going to do is I'm going to say, how many things are you trying to insert? If you try to insert more than one, I'm going to throw an error and say, wait a minute, that's not supported. You can't do that. You just get an error thrown. So I count how many are coming in, inserted. There's the inserted table. Count them. Is it more than one? Are you trying to insert more than one row at one time? Can't do it. Throw up my hands. Die. I'll show you how you're just going to get this message: multi-row insert not supported. You just can't do it. Okay, given that you got one insert, one row, I'm going to go get the PID and the PName from inserted. I only have one, so I go get the PID and the PName. Why did I do this? What? I only have one row. It looks like this. Let me go down to my insert player. I'm inserting the players like this. No, there's no else. This is insert into RPS players. When it throws that error, that's what you call a punch out logic. When it throws that error, you don't have to do anything else. The error aborts immediate. That's one of the few things you can count on not executing any further. When you hit that throw, the error propagates up, and you're done. So you got more than one row coming in. We don't handle that. We just do one at a time. Go ahead. More than one row coming in means insert into RPS player. Look, two rows at the same time. This one will trap. Let me execute. And now I'm going to try to insert 2 rows in one time. When I execute, I get this error message that says procedure through a error, multi-row insert not supported. You'll get that error, you'll get that message back through the front end. It'll come back to your form. So when you throw that error 50,002, that means that you've tried to insert multiple rows in a trigger that doesn't support them.
So carrying that forward, like that error, you threw an error for somebody trying to put in the same user ID, that error would propagate back to the form or the direction.
It would, yes. I usually don't throw an error unless I have to. The reason that I'm throwing the error is if I allow you to get any further with a multi-row insert, that trigger gets real squirrely and I'm not sure what it's going to do. It'll take one of them and not the rest of them, and it really gets strange. So it's easier to just do a hard abort with an error. Now, if I can handle it any other way, I will. Okay. But multi rows, I can't write that trigger here. I mean, it probably could be done. I'm just not good enough to write it. Okay, let's look at what I do. When after I get by that, so in other words, I've got one row, that's what I want. Then I select the PID and the PName, the ones coming in. Now I'm going to check them. How many, do I have any of these PIDs? How many of them do I have? Better not, I better have 0. If PID is null, PID can't be null, or the length of PID is equal to 0, or the count is greater than 0, the count could be 1, I could already have it, checks the PID, or PName is null, or the length of the PName is 0. Okay. I'm going to write the errata table and throw the error. So writing the errata table is my log. Something went wrong that hit the guy, but I didn't let him hit the table constraint. I bailed out before I got there. Else, insert.
That bailout before reaching the table straight is
Yes. Yeah, I don't really need this else. If I hit that throw, it's gone. It probably would be good to have an else up there where you mentioned it. I just found it made it look a little more complicated. I like having elses. I do not like the throws. I noticed this on line 47. I found that I was trying to get this to work, and when I did not have that, notice that it's kind of strange. I wasn't expecting a semicolon there. It's strange. You have a copy of this file. If you take it out, it bombs the throw. I don't know why. I've got to do a little research on it. So I'm playing it by ear. So I insert into, so if we get past this one, the trigger hasn't detected an error, insert. Notice I get the date here. I let the trigger handle the date. The ID goes on through, P name. Okay, the procedures are always my first line of defense. Here's a procedure, create, alter procedure, RPS, insert player. This is going to do about the same thing. I'm going to check these data 3 or 4 times before they get to the table. So I'm going to do exactly the same thing here. Count. Do I already have that PID? That count had better be 0. If that count isn't 0, so it's the same if. If it's null, if the primary key is null, or the length is 0, or I already have one of them, or the name is null, or the name is null length, begin. I might write the errata table. I don't know. That's something you think about. Is it an error if the procedure that's doing your inserts detects the error? You're catching it at a high level. I don't know whether it's an error or not.
So would you do that kind of redundant error checking David kind of in different places? Is that sounds a little redundant?
Well, okay, I'm going to grant public the right to use this this routine. I'm not going to grant public any rights at all on the RPS table. They only get the right to execute this routine. So if they execute the routine and they put something in that's wrong, is that bad? Nah, they're going to do it. Okay, now let's step down another level into the trigger. If a person if I get bad data in the trigger, what does that tell me? That tells me that somebody executed SQL code against that table so they can see the table. Otherwise, they would never have been able to execute the code. So they've gotten a step closer to me. So this is stopping them at the farthest arm's length. If they hit the trigger, now they're closer to me and I'm not as happy about it. So that's why I say we might write the errata table here. I don't know. It's not a huge error. If I get bad data into the procedure, well, okay. If I get bad data hitting the trigger, so the procedure protects the trigger. The trigger protects the table constraints. Well, if I hit a table constraint, I really want to know about it because that's getting real close. Okay. So this guy's going to catch errors. It's like your windshield catches bugs. I mean, they're just going to hit it. So I might write the error table. I set the error flag to 1. I've got an error. Then I try to insert. I might have an error in the insert. I don't know. There might be an error in the insert. I can't think of everything. I've tried to think of everything, but I probably not. So I try it there. And if I get an error from this, I catch it, an error flag of 2 is worse. And then print will depreciate, so I print the error flag if I have one. Otherwise, I just say, okay. The errata table. I have not yet. The errata table is fairly easy. It's a fairly simple one. It has a primary key that's assigned by a sequence. It has a date stamp, and it has copies of every field in the database. So it's probably going to have 20 or 15 or 20 fields. None of them are required. None of them are constrained. Whatever you try to put in there, when I get an error, I'm going to write everything I have in that incoming record, I'm going to write it all to errata.
Or the column of the error table will be
A lot of them will be null. So if I get a bad player, I'm going to write the player name that came in. I'm going to write the player name, the player ID that they tried to put in. I'm going to write the player's name that they tried to put in so I can go back and reconstruct what happened. I don't know whether just right at my first procedure, though. When I detect it right at the very first level of my defenses, I'm not sure I'd write that to the errata table. I'm only going to write the errata table if it hits the trigger. Okay, let's see, test. Okay, execute, insert player. Got a null primary key, should that go? No. Let's see what our error messages are. Execute. RPS player detects errors. Error 1, high level error. I mean, very first level. Not worry about it. Here's another one. Can't have a null real name. Again, another one, a zero length. Another one, zero length real name. And then finally, that might be a valid player. Killer 1 and Bob execute, and that one went. But none of those hit the constraint. None of those hit a table constraint. None of those hit the trigger, or were thrown out by the trigger. They all executed in the trigger. But okay, let's look at some more. This is inserting into the trigger alone. Now, what about this one? I'm putting in Sam. You can't go in. You can't have a null name. Now, this one's being thrown up from the trigger. Okay, so this is getting closer to me. This is coming from the database now. It wasn't a print. It wasn't my subroutine taking care of it. I bypassed the subroutine. This is a more serious error, because if I can write this code, if I can execute this code, I can see that table. I'm executing SQL code. You don't want me to do that. You got to figure out who I am, and this one's going to throw an error, and this one's going to throw an error.
Looks like there are three defense areas. You sure this is this one has the constraints?
Right. First one is the table constraints. Then the next one out is the triggers. The next one out is your procedures that do the insert and the deleting. If you delete, I won't let you delete. We're never going to delete from this. And then the fourth layer is the form, but you're going to get through the form if you're any good at all. So since the form has to have your connect string and all into it, you know, if you can't get through the form, you're not a very good hacker. Because you drop out of the form and you'll be able to find the routine that inserts the players into the game, into the players table. That's this routine right here. You'll find that, and you'll be able to execute that, because you have to be able to execute that. It's got to be facing the public. So that's going to get lots of static on it. And so I want to catch everything I can there. But right now, I'm a little closer right now, because I shouldn't be able to execute this. Right? If I'm going to do the grant, execute, on. RPS insert player, 2. Let everybody in the world execute that. Now, maybe I could just, you know, maybe I'd have a smaller subset. But basically, I don't really know who all is going to be coming into this, so I have to let people use it. Let me see, new query. Do I have a public user? Okay, I need to create a public user. So that'll take me a few minutes. I don't want to get bogged down in that right now, but by the next time we come back here, I will have a public user created. The public user will have no rights at all to that database. He won't have the right to see the table, to know the name of the table, to know anything about the table. The only thing he knows is he's got the right to execute that procedure. So he executes that procedure and it does whatever it does. But he doesn't know what that is. And he gets back certain information from it. So, for example, he can get back those, he shouldn't ever get back that database error, that red one. No matter what you put in to that procedure, it shouldn't ever throw a database error from the trigger. All you get back is, sorry, that's no good. Error detected, that's a 2, there's a 1. Errors, errors, errors. But then when you finally get it right, it says, we took it. But you can't see the table. Right. Now you can find out what's in the table by trying to do inserts. Yeah. And that's one of the attacks on you try the insert, and if it succeeds, oh wow. If it fails, that means that somebody has that primary key. It's like you ever gone into a storage place and okay, you know, pick out what pin number do you want? So you pick out a pin number. I want 1, 2, 3, 4. 2, 3, 4, 4. And sorry, you can't use that when that one's already taken. Well, what do I know? 1, 2, 3, 4 is going to open the door. Duh. So this will be an involved project. Okay, let's do this. Let's start with one table at a time. Okay. Why don't you try it on the game or games table? I suggest if you call it players, call it games, call it rounds. It kind of bugs me when one of them's plural and one of them's not. So the games table, and the games table has what in it? It's got a unique identifier, ID. Now that one you're going to assign from a sequence. Okay, so you need to create a sequence. Date. The date is just get date. You can get date. Player 1, player 2, referencing the players table. So that means that before you can put the player 1 and player 2 in, they have to be in the players table. So that's something to check. And then as you build that procedure on there, you have to check that they're in the players table before you try to put them into your table. So you have to check all of those parameters. Are they valid? Because you don't want them to hit the foreign key constraint. You never want to violate a table constraint. That's the whole idea here. The table constraints are like the net under a trapeze artist. You never want to hit that net. That's a good metaphor, I guess. Never want to use your airbag. Even if it's there for that reason, you know, you don't stop with your airbag. Okay, so let's try the games, and I'll be ready. Make it do kind of like what this one does. Okay, and you can put an insert. You have an insert trigger on it that checks everything. So the insert trigger can go check the players table, make sure that they're in there. The insert trigger, so it can check P1 and P2. Are they in there? It can check. It can check that they're not equal. They can't be the same. What also it can do is it can say if player 1 is greater than player 2, it can swap them before it inserts them. So now they're always in alphabetical order. It can check to see if it's already got them in the games table. Okay. So you try this one for next time. Bring it in. We'll take a look at it. Make some suggestions. You try. You're going to write the games table. You'll write a procedure that inserts into the games table, and you'll write an insert, and instead of insert, trigger on the games table. Basically, their job is to check everything. Check it all twice. How many parameters do you have? Let's see, G1, the game number is not a parameter. It's just, you're just going to grab that from a, so you've got player 1, player 2. Basically, all you've got to check is player 1 and player 2, because the user isn't giving you the primary key. You're creating that yourself. So if you take that from a sequence, you don't have to check that. You just have to check player 1, player 2. Are they equal? Are they the same? If so, throw it out. Is the pair already in the table? So the first thing I'd do with it, I think, in the trigger, I think I would say is player 1 great. If player 1 is greater than player 2, flip them. Then I'd check, do I have the pair player 1, player 2 in there? So select where P1 equals player 1 and P2 equals that. And select the count. If that count is 0, then you can put them in. So they have to be in the players table, not be equal, and the pair cannot already be in the games table. Three things to check.
Right now, are these things that are listed in document?
Let me work on that document some more. I'll add to it and send it out.
So please, can you repeat the list of things that you'd like for us to?
Okay, we're gonna for next time. Step 1, I want you to create the games table. Well, that's just create table. Okay, referencing the players table. So you got 2 foreign keys into the players table. Put check constraints on it as everything you can. Put them on there. Basically, I see it having 4 fields. It has the game ID. It has the player 1 identifier and player 2 identifier, and the date. Game ID is going to get assigned from a sequence. The date is you're going to take the system date. So all you got to do is check player 1 and player 2. So I'd start with player 1. First, is player 1 in the players table? 2 or 3 ways you can do that. Then is player 2 also in the players table? Okay. If player 1 is greater than player 2, swap them. So you keep them in ascending order or whatever, so you get them in a known order. Then check to see if that pair is already in the games table. If it is, throw it out. If it is, reject it. If it passes all of those tests, well, let's see. Are they both in the players table? I'm going to call that one test. Are they equal? Has to be no. Does the pair already exist? So there's 3 tests you're going to do. And you're going to do those 3 tests in the procedure and in the trigger. And I will put that into the Word document and get a updated copy of the Word document out. This is, it's kind of a big project, but it can be kind of fun as you start getting a feel for this programming. It's a lot of detail to it, but once you get a feel for it, the details are the same on all the tables. So what you have to check and how you check it and how you build the trigger is going to look a lot like the one I wrote for you. So you can take that one, change the name, modify it a little bit, change the tables, the row count, or you know, check getting the count of the rows from inserted. Let's throw an error. Now you can put an else there if you want to. Yeah, probably should have an else. Questions? Okay. I'm going to wrap up there for the night. Just because you don't necessarily understand everything about doing the games table, don't let that stop you from doing it, where that our reach should always exceed our grasp, and that it doesn't hurt to try to stretch for it. Don't be afraid to have it make a mistake, okay? Just because you don't just have some method to your madness, okay? So when I set out to write a trigger, I just want to get a trigger that when I try to insert something, it prints hello world. Are you alive? You know, are you executing? Okay, now can I make it do one more thing? Can I make it abort on a multi-line insert? Then I try to insert a multi-line, and does it bomb? And else prints, bless you, my son. So you get it running in pieces, and your understanding of it is happening in pieces. So each time you're trying to get, instead of just sitting down, what you can't do on this one, you cannot sit down and just play this one. Roll up your sleeves and just play it, just type it, the whole thing, because you will get something and you'll have a page full of errors, and that's very demoralizing, right? I'd rather have 2 lines that work, that I understand. You know, if all my trigger does is say, hello world, jingle bells, it's doing something. Then if I get it doing that, I can probably get it doing something else. Okay, so much for my soapbox. I'm going to end the recording. Stopping recording.